Hi, welcome to an Arduino tutorial from Robojax. My name is Ahmed Shamshiri. In this video, I'm going to show you how to use 2 or more, maybe up to 10 push buttons can be used with one analog input of Arduino, so you can save the pins. And when I press push button number 4, 4 is pressed. If I press 3, 3 is pressed. 5, 2, 4. An appropriate output is also on. With 10 push buttons, so we can press between 1 to 10 and detect it. So these push buttons can be used to control relay, load, LED, or whatever you want to control with. And using it with Arduino Mega and 10 push button switches. With Arduino Dewey, using Arduino Nano, also with Arduino MKR. I'm also going to test the code with potentiometer as well. You can get the code for this project by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. This is a detailed tutorial video where you will learn and customize this code for many other applications. If you don't want to learn and just grab the code and get the wiring diagram, then here is the wiring diagram. Get the code from the link below this video in the description. But if you want to learn and be able to customize this code and all your questions answered, stay tuned. There are instances that you need to use many push buttons, but also you run out of the digital pins that are used. So this was one of the solutions that I've seen people are asking for it, to use analog input. So I wrote this code and experimented. So we can use push buttons. So you can use these push buttons to control any of the digital pins of your Arduino board to control relay or load or LED or whatever you want to do with this. So here's the schematic. We have 5 volts, and then we have R1, R2, 3, 4, and 5. These are all 1 kilo ohm resistors connected in series. And then from 5 volts up to just above the ground, from each we have a wire that goes to a push button, and it comes here, is connected to analog 0. All of these push buttons are connected, all of them, to the same analog 0. And when the push buttons are not pressed, then we need to have a resistor to keep this input not floating but connected to the ground. I use here 1 kilo ohm, and here is 100 kilo ohm 100 times, but you can use 20 times, 50 times, it will be fine. So, but keep that in mind that you cannot have them very close. For example, you see here, this is 1 kilo ohm, and if you use 10 kilo ohm, you will not be able to read properly, because 5 of these will be 5 kilo ohm and this will be 10 kilo ohm, and you will have issue. So make sure that it is at least 20 times or higher. In this case, I used 100 times higher. So the bigger this resistor, the bigger the ratio of these two, the better the reading. And here are the main features. We need the same value of resistors for all resistors that we use. We need the same number of push buttons as the resistors. And if you're using 5 push buttons, then you need 5 resistors. If you're using 5 volts Arduino boards, you can use more push buttons, as opposed to 3 volts, 3.3 volts boards, which you can use less push buttons, because the voltage, when you divide it, there will be space between each value. And if you use 1% tolerance resistors, then you can use more push buttons, but you can use also 10% if you don't have 1%. And also we need a resistor from ground, from analog to ground, to avoid the floating of the input. And this resistor should be 50 to 100 times of the main resistors. The reason for that is, and this is the reason, when you have ground, none of the push buttons are pressed. This pin will be just floating if we don't have this ground resistor. So you need a ground resistor to always keep this pin ground or 0. In this case, I used 100 kilo ohm. So if you use this push button, we have these 4 resistors in series. It will be 4 kilo ohm, and it will be connected here. And if you use second push buttons, these 2 will left for the ground, and these 3 will be at the top. And then if you use this push button, it will go like that. Push button 4 and then push button 5. When you use push button 5, you connect directly 5 volts to analog 0. The voltage of your Arduino, if you're using Arduino Nano or Micro that are using 3.3 volts, the number of push buttons will be reduced. But in those also you can use 5. But Arduino that has 5 volts voltage, you can use even up to 10 push buttons or maybe more, depending on the tolerance of the resistor. These are the carbon film resistors. So if you're using these metal film resistors, these have tolerance of 1%. When the tolerance is very high, you can use more push buttons. So keep that in mind. But generally, these 10% will work for the 5 push buttons that I've just tested. And here, when we press push button number 4, we have 1 kilo ohm at the lower section and 4 resistors at the top. And the equivalent of these two as parallel would be 990 ohm. When you have two resistors in parallel, if you put your ohm meter across this section to read the total value of both, then for our total we use this formula, 1 over R1 plus 1 over R2 will give us the R total if these two have a different value. But if they have the same value, you just divide it by 2. And the voltage that will be detected, 0.99 volts. That's 1 volt at the analog pin. And when we press push button number 2, then we have two resistors, 2 kilo ohm and 3 kilo ohm is left at the top. And the equivalent of these two is smaller than 2 kilo ohm, which is 1960 ohm. And the voltage will be 1.98 or 2 volts. When we press push button number 3, then we have 3 resistors below the push button, which is 3 kilo ohm in series, and with parallel with 100 kilo ohm would be less than 2 kilo ohm, which is 2912 ohm. And at the top we have 2 kilo ohm. The voltage is 2.96 or 3 volts if you round it. And if we press push button number 4, then we have 4 resistors below this push button and 1 kilo ohm left at the top. So this 4 kilo ohm with this 1 kilo ohm resistor would be less than 4 kilo ohm, which is 3846 ohm, and the voltage will appear to be 3.97 volts. So this is rounded to 4 volts. And when we press push button number 5, we are connecting directly the 5 volts. We do not worry about these 5 resistors, but even if you calculate it, these two will be parallel with 100 kilo ohm, and the 5 volts will be directly connected, and this resistor has the equivalent of 4761 ohm, which is smaller than 5 kilo ohm. Some people might ask question that how about if I use different resistor value? Yes, you can use it, but this code cannot be used for that, because in order to use the same value, the code will look very clean and easy. Now let me explain the wiring. In order to prepare these push buttons with the resistors, I've connected, let me remove these. First, to prepare your resistors, get the same value resistors. I've connected them such that from here they are connected to a point where I put another resistor. So this resistor is connected to this because this line is the same. This is short circuit, all these lines. I have separate video explaining how to use breadboard. The link for the breadboard video is below the video in the description. So from this point, I have connected another resistor to a point where I connected the second, the third resistor, and then the fourth, and then the fifth. From the fifth one, this is the 100 kilo ohm resistor, or the resistor that is 100 times or 50 times greater than these values. From this point, it is connected to this line. This is all connected. I have spaced these wires such that from the junction between the two resistors, if you count this 1, 2, 3, I put this wire and connect it to this point, and between these two, again, 1, 2, 3. So this is a space for this push button. 1, 2, 3, and then between these two, from this point, 1, 2, 3, and then between these two, 1, 2, 3. And from here, also from the last one, We have 1, 2, 3, and it is connected. To put the push button, we will connect our push button between this wire and the junction between this resistor. And then the next one will be at the line where the wire is and at the junction. So this will be connected. And here. And here. The third one. The fourth one, and the fifth one, the last one at the top. Now for the wiring, because this is connected to analog 0, connected in here, and then this will go to analog 0 here, to analog 0. And then from 5 volts and ground, I got the red is 5 volts and the ground is blue. This is our ground, where this 100 kilo ohm is coming, and all the resistors are coming to the same point. And this last resistor and 100 kilo ohm are connected to the ground. So that is connected, and the 5 volts will be connected at the first resistor. Here, the 5 volt is connected at this point, which goes to the push button when we press it. And this is now connected to the resistor at this point. If I remove the push button, you can see it. Like that. From here up to here. The only difference in the wiring is that I put here a jumper because I connected two pieces of two breadboards here. For that, I just put this extra wire. Now let me explain the code. At this line, we define number of push buttons count, and you put the number of push buttons that you have, in this case 5 push buttons, and the resistor value that we use is 1000 ohm or 1 kilo ohm, and the resistor to ground, the resistor that we are using to be connected to ground, that's 100 kilo ohm, and that is referring to this resistor from analog pin to the ground. Then we define analog pin, in this case analog 0, and here we define our voltage for our board. In my case it's 5 volts, but if your board is 3.3 volts, you will put here 3.3. And this is now array that is holding a string value for push button name. I have defined this as push button 1, 2, 3, 4, 5, 6. 5, and these two extra we can delete it, but if you have more, it has no harm, so I just left them there. And push button value, these are also the value for each push button, either as true or false, because it's Boolean. When we press it, they will be stored in here. So we must have the same number of count that you have, you must have it here, or higher. So in this case, it's 7, but we can put also 5. So as I said, more than the value has no harm, but less will give you error. And here we define output pins. Pin 2, 3, 4, 5, 6. If you want to control a relay, an LED, something, whatever you have, so you can control the pins here if you want to use it. And push button delay time, this is the time when you press the push button and release it. So up to 100 milliseconds, if your hand shakes or press it twice, it will not be counted. So up to 100 milliseconds will be counted as one push. If you want to increase it, you can do so. So you can hold your hand, for example, for half a second if you set this for 500 milliseconds, and it will be counted as one. This is the tolerance for the resistor. I'm using 10% tolerance resistance. For 10%, put 0.1, and if you're using 1%, for example, type 0.01, and for 5%, type 0.05. Debug true, this is a value. When you set it to true, it will show you a lot of values. For example, the calculated value for the voltage, the minimum, maximum, and actual voltage. So many values will be printed, which in your normal operation you don't need it. So when you don't need it, just type false. This is a bit resolution for majority of analog to digital converter of the Arduinos. It is 10 bits, but in some Arduinos, if it is 12, type here 12. Our total is a value that is holding the value that is needed. This is a prototype for read push button, which is a function at the bottom of the code. Inside the setup, we define the serial monitor with 9600 baud, and if I click this, as you can see, the debug is now on. It shows here on the right side at the lower, it shows 9600. I'm going to come back to this screen, and this is just printing the text, and it prints number of push buttons, and then this text will be concatenated or be after this text. We see this, and this array goes from I from 0 to 1 smaller than push button count, and defines all those pins that we have using pin mode, and picks up the pin number from the array at the top based on this I becomes 0, 1, 2, 3, and it gets the pin and sets it as output. This I, when it goes to this array, it comes here. When I is 0, it picks up 2. When I is 1, it picks up this 3, and so forth. So when with 0, it picks up this 1, 2, 3, and with 4, it picks up the 6 and brings it here. This is as if I type, for example, if it was 5, I will type 6 here as an output. So this pin will be defined using this array. It makes it, instead of 6 line, we just put this. And inside the loop, we use this function which says read push buttons. So it reads the push button value, and the values for each push button, which is either pressed or not, will be stored here. So whatever push button is pressed, one of these will be 1 or true, and false or 0 if it is not pressed. Now let me explain this before we come here. So this read push button is a function that does a lot of work here. First, we define voltage calculated, or total, voltage minimum, voltage maximum. All these variables of type float are defined, which are used next. Then we use analog read, go to the analog pin, whichever pin you define at the top of the code, let's say analog 0. The value, which will be from 0 to 1023 in 10 bits system, will be stored here, and then we get that value and convert it to voltage by multiplying to the voltage, which is 5 volts, divided by 1023. So how we get to 1000? So how we get 1023 is that this power means 2 to the power of bit resolution. So this power of bit resolution is 10, so 2 to the power 10 will be 1024, and we subtract 1 because in our counting it starts with 0, so we have 1023 different positions, steps. So 5 divided by 1023 is a fraction, multiplied by this value will give you the actual real value of voltage. In this line, if you set the debug equal true, it will print the debug information. It prints this text, the voltage, which I'm going to show you, and then it types V at the end. So these are just for debugging, and then it prints number of push buttons with this text. Here we check integer I goes smaller than number of push buttons, so this I changes 0, 1, 2, 3 up to 4 in 5 push button system. And here we calculate R total, and here how we calculate the R total of 2 resistors in parallel. For example, we have R1 and R2. If you put your ohm meter across these two, the R total or equivalent value is calculated 1 over R1 plus 1 over R2. So it will give you the R total. If these two have the same value, you just divide it by 2. So that formula have been implemented here. 1 over R1, that is R1. So we get the resistor value, which is 1000 multiplied, so we make it float, multiply by the position of the resistor. If we have 4 resistors, it will be 3 plus 1, which is 4. So 4 kilo ohm divided by 1 over 100 kilo ohm in this case. So it will calculate based on the position of each resistor, each push button. And from this, when we get the R, then we can calculate the voltage. So R times the source voltage times 5 volts divided by, this is a formula to calculate, that's the formula to calculate in 2 series resistors, it calculates the voltage. And here we check if the push button is, if I plus 1 is equal to the push button, then we know that this is the last push button. Then we know it's the last push button and there is no other resistor, so we don't worry about the calculation. Whatever is the voltage will appear at the analog pin. So we just say voltage calculated is equal the source voltage. And here we get the minimum and maximum voltage. Here, for example, in a 10% tolerance, if you want to calculate 3 volts, if this is our voltage, we go 10% high and 10% low. And when you go 10% high, it will be 3 plus 10%, 3.3 volts. And if you go to the negative side, 3 minus 0.3%, so it will be 2.7 volts. So we get 10% high and low, and because the resistors might be going up and down, so we need to find exactly. So our range will be smaller than 3.3 volts, smaller than 10% higher, and greater than 10% lower than 3 volts. So this is exactly what we do. So we get the actual calculated voltage minus, so this is 10% subtracted, and then 10%, this is the whole thing, this is 10% added. So when we add 10%, that's the maximum. When we subtract, it is minimum. So we have these variables which will be used next. And here, this is also for debugging. So this is just printing it if the debug is set to true. And if it is not last push button and debug is true, then we print all this. This is just fixing the value to, so it looks nice. And this is a calculated VR, minimum, maximum. I'm going to show you on the screen what it prints. Those are not important. And here we check if measured voltage is smaller than maximum, which means if it is smaller than maximum, which is 3.3 volts, and higher than 2.7 and higher than minimum, then that's our voltage. So this ampersand means this value, the result of that, and the result of this portion. If that is true, then we set the push button value based on I, which is 0, 1, 2, 3, depending on the push button, we set it to true. This is the array at the top of the code, which we set with all 0, 0, 0. Here, the corresponding value to the push button will be set to true. And then this is a delay that we set for the push button. So in case if the person has pressed the push button for this amount of time, it will not pass, and it will keep it at that position, so it avoids multiple pressing. And we say else, otherwise we set that value in the array to false. And we use a for loop to go through each value, and here we check with I, we go and check the value. If it is equal true, this means if this is equal true, this automatically it means true. It would have been excess if I had typed like this. So if that is equal true, so this was extra. This is exactly the same. If it is true, then we print this text on the screen and print the corresponding text from the push button, one of these texts. So using this function, you can control relay, load, or whatever you want. And in this line, we go to control output and pass this I, which is 0, 1, 2, 3, 4 accordingly, and it will turn the output high or low. Let me explain it. And here that I comes here, and first we use digital write and pick up the output pin from the array. And here, when I is equal 0, I is equal 1, I is equal 2, 3, and 4. We get that pin and set it to high. So this will turn the output high here. So this can be a relay, a load, whatever you want to do with this. And if your relay needs low, change this to low to turn it on. But majority of stuff would need high, so I put high here. And these are just the text to print the corresponding pin on the screen. So let's go back here. It has 100 millisecond delay, and the loop will continuously take the same action over and over again. And here is a demonstration now. When I press a push button, the result will be displayed here. Let me press push button number 2. As you can see, it shows push button number 2 was pressed, and also it shows pin 3 is on. So whatever you have connected to pin 3 will be also controlled. Push button number 4, 5, 1. It is detecting it perfectly. And now I've turned the debug to true, so it shows everything. Let me open the screen and stop it. So you can see here, it shows 5 push button, measure voltage because I have not pressed any push button. It is 0, so resistor for push button 1 is 990 ohm for this calculation with 100 kilo ohm. The calculated voltage is 0.99 and minimum is 0.89 and maximum is 1.09. And the same way for the push button 2 resistor, it's 1960 for push button 3, push button 4, and these are the corresponding voltages. So 3.97 is, this is actually 4 volts, so 3 volts, 2 volts, 1 volt. But here the minimum maximum based on 10% is also calculated, so it will tell you the value. Now I leave this and then I push one of the buttons. So it says press push button 3. Let's see, we read 2.97, and if you press push button number 3, so we get 2.97, and our calculation shows to be 2.96. Very accurate. So if you're not using it, just make it false. Number of push buttons to 3, and I'm going to demonstrate it. And I have also 3 push buttons. Let me reset it so you can see the text. I'm pressing this reset. So 3 push buttons, and let's press push button number 3. So it says, let me hold it so you can see it. Push button number 3 is pressed. Push button number 2, so pin 3 is on. And if I press push button number 1, let me push it continuously so you can see push button number 1. And now I have set debug to true for the 3 push buttons. Let me open the serial monitor and stop it. And as you can see here, for 3 push buttons, push button number 1, the resistor is 990 ohm and the voltage should be 1.66. And here are the minimum and maximum. And push button number 2 will be 1960 ohm. And then we have 3.3 volts, and these are the minimum and maximum. Now let me demonstrate it with 10 push buttons from here up to here. The only difference in the wiring is that I put here a jumper because I connected 2 pieces of 2 breadboards here. For that I just put this extra wire. As you can see, it says PB10 is pressed, 9, let's go, 8, 7, I'm pressing it twice, 6, 5, 4, 2, 1. So all of them perfectly. Now I have set debug equal true. Let's open the serial monitor. I'm pressing now number 6 and then stop it. Let's see, push button 6 is pressed. What was the voltage? Here we read 2.93 volts, and let's see for push button number 6, the calculate is 2.93, and then lower will be 2.64, and 10% higher will be 3.22. So this is perfect. And here's a demonstration using Arduino Mega. I've connected the same 10 push buttons here. Let's press number 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Just randomly. As you can see, it responds perfectly. I've connected it to 5 volts. And the test using Arduino Nano also shows it's working without any issue. And here with Arduino DUI, when I press 10, still it shows 10, 10, 10, and finally this shows 8 and 9, even though the code, everything is correct, and the bit resolution is set properly, so it will not work with DUI. Perhaps it needs some extra work to fix it. I tried to use it with Arduino MKR, and when I press it, it shows the wrong pin. All the values are messed up. I measure the voltage. The voltage is correct. As soon as I connect Arduino, this analog pin, the voltage is being distorted, and I could not find any documentation explaining why it is affecting the circuit. The impedance of this is affecting the circuit. So this will not work with MKR. Now let me demonstrate it with a potentiometer or variable resistor. The right pin is connected to 5 volts, the left pin is connected to ground, and the middle pin is connected to analog 0 here. And I've set it to 5 resistors. And let me now rotate this. It says push button 2 is pressed. Let me go back. Push button 1. So wherever it matches, push button 2, and then let's go a little higher, push button 3, push button 4, and then if I go maximum, it shows push button 5 is pressed. So different level of voltages can trigger something if you want to use it this way. Now I'm changing it to 10. Now at the middle, it is around 4 or 5. So if I go here, it shows 7 now. 8 and 9, the value is in between. 9 and 10, or 10. And if I go somewhere here, 1, 4. Thank you for watching an Arduino tutorial from RoboJax. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos. In this tutorial, I'm going to show you how we can measure any DC voltage with Arduino. As you can see now, it is 12 volts, and we are reading 12 volts in serial monitor. I'm going to explain how to calculate different resistors to measure any voltage. Also demonstrate 12 volts, 24 volts, 36 volts, and 50 volts. At this point, I have a resistor, and this is called voltage of R1, and this is voltage of, and selecting R2 at 22 kilo ohm. We can measure with Arduino is 25 volts, 23.5, 23.4 milliampere. So we get 5 kilo ohm resistor. This is the formula to calculate R2 for your application.